Okay, we have some problem situations today. So let's just look at this. Our notes just tell us to set up the problem, identify variables, draw a picture. We're going to decide what operation we're going to use. We're going to simplify. We're going to reread the question, see if we've answered it. So let's just get started and see what each question has in store for us. This looks a little fuzzy. I'm going to see if I can make it unfuzzy. Hang on. Okay. Kelly wants to build a sandbox. She wants the length of the sandbox to be 3 feet longer than the width. Write the expression that would help you determine how much edging Kelly needs to enclose the sandbox. Okay, so when I see a problem like this, I know we're talking about length and I know we're talking about width. And so I'm going to define my variables over here off to the side for length and for width. Whichever one it doesn't say anything about, doesn't give a description about, I'm going to have that be my X, or whatever letter I choose to use. So right here when it says she wants the length of the sandbox to be 3 feet longer than the width, W, okay, they're telling me to let W be the width, so they actually told me to let W be width. But even if they wouldn't have put that W there, I was going to do it anyway, because when it gives this description of length, it says the length of the sandbox is 3 feet longer than the width. It gives a whole description of length, but it barely mentions width. The thing that isn't described, I let that be my X or my W or whatever letter. Now let's go back to length. It says the length is going to be 3 feet longer than the width. How would I write 3 feet longer than the width? W plus 3. So longer than, that's a switch word. And so width is W, longer than is plus, and then I come back to the 3. So it says the length is 3 feet longer than the width. So 3 feet longer than W, W plus 3. Okay, now it wants to know how much edging she needs to enclose the sandbox. So if I had a sandbox and I want to know how much edging she needs, edging is this around the outside. So is edging perimeter or is edging circumference? Area. Is edging perimeter or is edging area? Edging is perimeter. Okay, so I want to find perimeter. So how do you find perimeter of a rectangular shape? Either add up all sides or 2 times the length plus 2 times the width. It's your choice. So if you want to add up all sides, we can do that. I know that the width is W, and I know that the length is W plus 3. So if that's W plus 3, that's W plus 3. If that side's W, that side's W. So if I want to know something about the perimeter, I'm going to add up all sides. So the W plus the W plus 3 plus the W plus the W plus 3. And then I just combine like terms. What do you get if you combine W plus W plus W plus W? 4W. And what do you get if you combine the positive 3 and the other positive 3? A positive 6. And that's the expression I would use to determine how much edging she needs. So this is her edging. Sorry about misspeaking a few times there. Okay. The next problem says, if the perimeter of the sandbox is 54 feet, what was the width and the length of the original sandbox? So this expression that I got here for perimeter, they're saying that that perimeter is 54. So I'm going to set my 4W plus 6 equal to 54. Because this is the expression I got for the edging, which is the perimeter, and I know that the perimeter is 54. Okay, I'm trying to solve for W, so let me circle everything smushed with it. What do I do to move the 6? Subtract. Add or subtract whatever's outside the circle. The 4W drops down. The equals drops down. How much is 54 minus 6? 48. And then I would divide both sides by 4. And if you divide both sides by 4, you get 12. So my width is 12, and this was in feet. And then length, if I look back up here to length, the length right here said that it is W plus 3. So you take your W answer and add 3 to it. So what's 12 plus 3? 15. So my length is 15 feet. And there's the answer to my problem. Okay. Next one. Kate sold 3 times as many magazine subscriptions on Tuesday as on Monday. She sold the same number on Monday and Wednesday. If she lets M represent the number she sold on Monday, what expression represents the number she sold on all 3 days? So off to the side here, I'm going to do Monday, Tuesday, and Wednesday. And it said to let M represent how many she sold on Monday. So M is going to represent how many she sold on Monday. Okay, right here I read that she sold the same number on Monday and Wednesday. So on Monday if she sold M, then Wednesday she sold M. Okay, in this first sentence here, it tells me that Kate sold 3 times as many magazine subscriptions on Tuesday as on Monday. In this first sentence, it gives me a whole description about what she sold on Tuesday. It said she sold 3 times as many magazine subscriptions on Tuesday. Monday wasn't hardly mentioned at all. So that's how I know that Monday would be just my X or my M or whatever variable. Okay, so what does this mean? She sold 3 times as many magazine subscriptions on Tuesday as she did on Monday. So Tuesday's amount is 3 times that of Monday. So how do I write 3 times the amount of Monday? 3M. Okay, and then it says, what expression represents the number she sold on all 3 days? So I want to add Monday to my Tuesday to my Wednesday. So Monday is M, plus Tuesday is 3M, plus Wednesday is M, and what do you get if you add up M plus 3M plus M? 5M. Don't forget these have 1s in front of them, you just don't see them. And that's the expression you would use to represent what she sold on all 3 days. Okay, let's flip the paper over. Number 3. A poster's length is 4 inches shorter than the width, W. Okay, so they're talking about length and they're talking about width. Off to the side here, I'm going to go ahead and define variables for length and for width. And it said to let the width be W. But even if they wouldn't have done that, that's what I would have done. It says a length is 4 inches shorter than the width. They give a whole description about the length. Width is barely mentioned. Whatever is barely mentioned, that's always just your X or your W or your single letter. Okay, now let's go back to length. It says the length is 4 inches shorter than the width. The length is 4 inches shorter than the width. How can I write 4 inches shorter than the width? W minus 4. Shorter than, remember, is a switch word. So I start with the back, width, that's the W. Shorter than, that's the minus, and then the 4. Okay, so this is a poster. I'm going to go ahead and draw that little poster. So it says the length is W minus 4, and it says the width is W. Okay, so this up here is W minus 4, and this over here is W. It said that Bradley wants to put a poster in a frame that has a width of 3 inches. So we want to take this poster and we want to put it in a frame. So here's this frame going around it. And it says the frame has a width of 3 inches. So that means the distance between here and here is 3. So from here to here, that's 3. and that means that the distance from here to here is also 3. Okay, same thing over here. The distance from here to here is 3, and the distance from here to here is 3. And then I can do that for all my corners. So this poster has a width of 3 inches. So from here to here, that's 3. And from here to here, that's 3. From here to here, that's 3. And from here to here, that's 3. Okay. Then the problem says, write the expression that would be used to determine the area of the frame and the poster together. Okay, so I want to find the area of the two together. Remember, area is length times width when we're talking about a rectangle. And it wants the area of the frame and the poster together. So all the way from here to here is my length, and all the way from here to here would be my width. Okay, so let's figure out what this is. I know this piece is w minus 4, and I know that this piece is 3, and this piece is 3. So what's the 3 plus the 3 give you? 6. So I would have the w minus 4 plus another 6. That 3 and that 3 making 6? Okay, well let's combine this. What do you get if you combine the negative 4 and positive 6? W plus 2. So that's my length. Let me go ahead and put that up there where my L is. Now I just need to figure out my width. Okay, my width is all the way from here to here. I know this piece is W. That's a 3, and that's a 3. So I've got my W, plus I've got that 3, plus I've got the other 3. And what do you get if you simplify that? W plus 6. Okay, and that's my width. And now I need to multiply these together. So it looks like I have two things to distribute. So I'm going to double distribute. First, let's distribute the W. What's W times W? W squared. What's W times 6? 6W. Now let's distribute the 2. What's 2 times W? 2W. And what's 2 times 6? 12. Okay, I want to combine like terms. What do you get if you combine the 6W and the positive 2W? A positive 8W. The plus 12 in the back, drop it down. The W squared in the front, drop it down. And that is the area of the frame and the poster together. Okay, number 4 says, how many ways can you line up x plus 3 boys and x minus 3 girls? This is wanting to know how many ways, how many combinations can I come up with? If you're ever trying to figure out how many combinations of things, then we're going to multiply. So I want to multiply my x plus 3 boys with my x minus 3 girls. Now I have a problem like up above, so I'm going to double distribute. First, let's distribute the x. What is x times x? X squared. What's x times negative 3? Negative 3x. Now let's distribute the 3. What's 3 times x? A positive 3x. And what's 3 times negative 3? Negative 9. What do you get if you combine the negative 3x and the positive 3x? 0. Shoop! That's gone. All you're left with is x squared and a minus 9. And that's how many ways we have to line up x plus 3 boys and x minus 3 girls. That's all, folks. Thank you.